I were in your shoes, and that would be, what grade am I now getting in this class? And there are two ways of figuring that out. If you take the sum of the three tests and divide it by 3, you'll get a number x. If x is 90 to 100, you're getting an A, 80 to 89, B, 70 to 79, C, and 60 to 69, D, below 60, F. And because you could drop the lowest test, done 3 tests, take the sum of the 2 highest tests, divide that by 2, and you get y. If y is 90 and above, you're getting an A, 80 to 89, B, C would be 70, 79, D, 60 to 69, below 60, F. And that's how you can determine where you are standing in this class. But there's still a lot of points left to go, and so I'll see if you have questions.
For the final exam, is that cumulative?
Yes. Of course it is. Have you ever taken a final exam that wasn't?
Yes.
Okay, I haven't. What?
That's it all the time.
Okay, not my class.
Will you be putting the labs in the grade book?
What?
Will you be putting the labs in the grade book?
Say it again?
Will you be putting the labs in the grade book?
At the end, yeah. I wait until it's all. After you have the final lab and I grade it, I put the total in. The reason I don't put in there the labs, because the labs, if you've been handing them in, you usually keep your grade the same or boost it. Why do I say that? I think I calculated it Saturday, quite this weekend. Friday was grading. It was all 3 classes I gave tests. That was like 700 pages I had to grade, plus 3 labs. And yesterday I did battle with Mother Nature, lead patrol, and I have a couple of big trees, so that was 3 hours of fun. But anyways, it's still fun to go out there and clean them up because I can still do it. All right, but anyways, the average was for the lab here, I think was 89.8, which is essentially an A. So if you're getting an A and you've had, it's not going to hurt you below an A, labs will boost you up a little. Does that help? Okay. By the way, safety tip today, even if you're driving like I have four-wheel drive SUV, when you're making a turn today, the intersections are awful. Driving here, by where I live up north, I saw the aftermath. I didn't see the accident where some person turned probably too fast and went right into a stoplight and wiped that out in his car too. And when I was coming here, right on Lambert, coming off Roosevelt, I was waiting and the truck made a turn. He was going too quick and he almost swerved like this way, and luckily caught it just to make a time before he took out a light bulb. So when you're making your turns, take your time. Go slowly, even if you have four-wheel drive. All right.
Is that a genre?
What?
Is that a genre?
Yeah, thank you.
Are we turning these into you?
What? You get to eat those. Just don't show the John, please. Thank you, Sam. All right. I don't know how many of you were on Blackboard since yesterday and have real eagle eyes. I use that expression eons and probably won't again. But if you look at Blackboard, you'll see a new thing right underneath course information. And it says extra credit project. If you click on this, you'll see extra credit project. Let's open it up. They have both as a Word and a PDF. And if you look at it, I didn't change it. That should be fall, not spring. I'll have to change that. I corrected it. Obviously I didn't. I got the right date in there. And bonus project, 10, yes, 10 bonus points. How do you get that? First of all, it's due November 2nd, which is test 4. There are no late projects accepted, period. Now, the extra credit project is to create a list of ionic and covalent molecules found in ingredient lists of products that you can purchase. IE, in case you don't know what IE is, that's Latin for that is, and things you can use in your daily life. You must find 5 different molecules that contain ionic bonds, and you must find 5 molecules that contain only covalent bonds. You can only use 3 molecules from any one product. To get the points, you must hand in, and this is important, not handwritten, but printed. And I think you all have access through COD to printer in the library or elsewhere. And you must have the product's name, the name of the molecule, and then if it's ionic or covalent. All 3 have to be correct to get a point. And since you're getting 10 points, you have to have 10 things. You get 1 point for each correct entry with a total of 10 points. Now, to make it interesting, there are a few things you can't use. You can't use gasoline, water, sodium bicarbonate, sodium bicarbonate, carbon dioxide, ethanol, also known as ethyl alcohol, sugar, or sodium chloride, also known as table salt. Everything else is free game. Now, your chart or table should look like this. An example would be product, Coke, molecule, water. I can put an example, but you can't use water in your table. And then it's covalent. And if you go to a can of Campbell's chicken noodle soup, if you don't know, either the low or high sodium is chock full of sodium chloride, and that's ionic. Ingredients must appear on ingredient list on the product. You can't say air contains nitrogen or oxygen, and that's covalent, because I don't see an ingredient list in the air in this room. And one person put down a scuba diving tank and said, show me a picture of the ingredient list. And there wasn't one. I had already looked it up. And it has to be on there. Now, this is optional. You don't have to do it. But if you do it, and get it correct, it's like getting 10, yes, 10 extra points on any one of your tests. It goes right to the bottom line, 10 points to your total, which is a good thing. Now, a couple things. First of all, how do you know if you have a compound that's ionic or has at least one ionic bond in it? And it's simple. Look at your periodic table. If it has any of the metals or alkali metals, alkaline earth, alkali metals, alkaline earths, and that will tell you it's ionic. So if you see the names sodium, calcium, magnesium, iron, tin, any of those, it will be ionic. So if you go to your periodic table, if you see lithium, sodium, potassium, or any of the others, magnesium, calcium, iron like iron, manganese, or cobalt, nickel, copper, zinc, those, silver, gold, those will all be ionic compounds, not elements, compounds. Now, to show you how easy it is, write one. With the cold weather on, I don't get any product kickback. I should find out how good oh look, buy this stuff, it's good. And most of you are familiar with is stuff you put on your lips in the winter, and we're in winter right now. If you look on the side here, you'll see ingredients list. And you'll see various things. And if you look at phenol, that's covalent. So if you put down Carmax, phenol, and covalent, that's 1 point. By the way, you can use Carmax phenol on your list. So that's 1 point. And you can get 2 more out of here that I'll let you figure that out. You can go other places too. And the rule is you can only get 3 molecules from a compound or a product, and that forces you to look at 4 different things. And what I'm really secretly doing is having you think about stuff on the ingredients list. Those are molecules that you're learning about in here. Now, as a public service to my students, how do you find out about whether a compound is ionic or covalent? You can use Google and get the structure or the formula. If you're not sure, by the name, and you can ask your instructor. If before it's due, even if you, at that point it's still handwritten, if you come to me and show it to me, I'll help you out and let you know you're doing it right or not. Which means everyone who wants to should be able to get 10 points. You know I'm ambidextrous. I am. But anyways, that's the extra credit project. If you have any questions, feel free to ask and see me. But I would highly recommend all of you do it because it's 10 points into the bank. That can never hurt. And it's easy 10 points. All right, any questions on the extra credit? Yes.
So basically, you need to find 5 ionic and 5 covalent?
Right.
Okay.
And they have to be, you can only get 3 from one product, so you have to do 4 products. And that just is my way of saying, look at different things in your daily life, and those are molecules on that label. You don't think of it, you can't use it, but if you were to pick up a bottle of pop, and that's a good thing to use, can't use water, can't use sugar, you tend to forget those are chemicals that you're learning about in this class. All right, let's continue where we left off. talking about acids and bases, which you'll learn are a very important part of our daily life. And just a little review to remind you what's an acid. An acid is a proton donor. What's proton? H+. You should know this. Everybody? Yeah. No. Acid. Proton donor. If you remember last week I had on the board, again, know this in bold, big font. What's a Bronsted-Lowry base? It's a proton acceptor. And if you remember last week I did the joke, if I have a proton and I come to you and say, here, take my proton, I'm an acid. If I come to you and say, quick, give me your proton, I'm accepting it, I'm taking it away from you, I'm a base. And again, acid, proton donor, base, proton acceptor. And I talked about some key acids and key bases, and let's go through that list that you should know by the structure. If I write on the board, on the test, is the following an acid, base, or salt, you should know the following are important acids in our daily life. HCl, and I won't ask the name, but you should know the structure, is an acid, hydrochloric acid. H2SO4, that's sulfuric acid, it's an acid. And HNO3, nitric acid. Again, I won't ask you the names, but if I draw the structure in acids, add an acid, base, or salt, that's a acid. And finally, vinegar, which contains water and acetic acid. Acetic acid, lo and behold, I won't ask you the structure, but you should know vinegar is acidic. And bases you should know, I ask on this test, is the following an acid, base, or salt? And I put down NaOH, sodium hydroxide, that's a base. KOH, potassium hydroxide, that's a base. Ammonium is a very strong base. And finally, a weak base, and I'll talk more about weak and strong, sodium bicarbonate, which you know is baking powder, is a mild, but it is a base. And again, you should know on a test, if I write down the following, is it an acid, base, or salt, and I write down this, which of the following are they an acid, base, or salt? Now if we look at the following, HCl, hydrochloric acid, it's an acid. Potassium hydroxide, you see OH, it's usually a base, is, oh, I was right, it's a base. Please pass the NaCl. Hope you all know that's salt. How much you're learning in my class now? You know about passing the NaCl. And those are acids and bases. And water forms with an acid, the hydronium ion. Now, it turns out acids and bases react with each other. If I have an acid, and the general way of showing acid in chemistry is HA, and I react it with a base, which we use the very clever letter B. And I don't teach it in this class, but there's something called an equilibrium. And equilibrium means you have a reaction going forward and a reaction going back. And if this is an acid, it gives up a proton. And if it gives up H+, it gives up the H, but retains the electron and becomes A-. And if base accepts a proton, it now gets the H, but the proton has a plus charge, so it now have a HB. Now, in chemistry, we use the term conjugate. Conjugate is a compound that differs from another compound by only H+. Conjugate, compound that only differs from another compound by H+. And if we look at this is an acid, and this side, here's the conjugate. And the conjugate in chemistry for acid-base reactions is always on the right of a equilibrium. Remember, right, left. These days I'll have a little sticker and put it on my hand, R, right, now that's too. Now, if I look at this compound, B, the base, and I look over here, HB+, they only differ by H+, and that's also a conjugate. Now, let's look at the reaction going this way. If we look at the reaction and look at A-, it goes from here to its conjugate on this side, the acid. Has it donated a proton or accepted? If you want to do these, just look at H alone. Is it gained H or lost H? And the answer is no H, it's gained an H. And what's something that accepts a proton? A base. Therefore, this is called the conjugate base. If we look at HB+, going to its conjugate, going this way, has this going from here to here gained a proton? Just look at the H, makes your life easier. Or lost H. It lost. And what's something that gives up or donates a proton? An acid. Acid, proton donor, base, proton acceptor. So this is the conjugate acid. let's look at the following. And the question would be, for this, label the following conjugate acid, base, conjugate acid, and conjugate base. Notice under this molecule I have W, X, using a good part of the alphabet, X, Y, Z. And the question is, how do you know what's the acid, what's the base, what's the conjugate acid, what's the conjugate base? First thing you always know, on the right, these are always the conjugate. So that's important. This is even more important. Hold on. Now, let's look at identifying the conjugates. How do you know something's a conjugate? It differs by H plus. But for you, just look at, does it differ by H? This has 2 hydrogens, a sulfur, and 4 oxygens. Oh look, this has a sulfur and 4 oxygens, but how many hydrogens? This one. So if we look at these are conjugates, because they differ by H plus. Now, if we look at this, NH3, NH4 plus, it differs by H plus. Let's count the hydrogens. So these are conjugates. Now, if we go this way, from here to its conjugate, has it gained or lost a proton? Count the hydrogens. 2 here, 1 there. Tough question. Did it gain or lose a proton? Time's up. Hope we all picked it. Lost a proton. What am I if I give up a proton? I am an acid. So this is an acid. And you put that down there. Let's go to this one, ammonia. And you know what it is, but anyway, still, look at it. Goes from NH3 to NH4 plus. Has it gained or lost a proton? Just count the hydrogens, forget about the charge. Went from 3 to 4, hopefully all agree that's gaining. What is something that accepts or gains a proton? A base. Well, 2 down, 2 to go. Quick, tell my stockbroker, sell. Anyways, can't tell the bondbroker that because they're closed today, because Veterans Day. And if any of you are veterans, happy Veterans Day. Thank you for serving our country. And if we go the other way, let's look at Y. Y here starts here. When it goes this way, and it's in equilibrium, it can. The reverse reaction has this gained or lost a proton going from Y to X. And the answer is it went from 4 to 3. I hope we all agree that's a loss. What's something that loses protons or gives it away or donates it? And that's an acid. Therefore, this is the conjugate acid. And let's do Z. Z starts here. It goes to its conjugate right here. Does it gain or lose a proton? Count the hydrogens. 1 there, 2 there. It gains or accepts a proton. What is a proton acceptor? A base. Therefore, this is the conjugate base. And that's how you do it. Let's do another one.
What is that?
By the way, there's no law in chemistry when you write it in a reaction, which goes first. Does the acid always go first? No. But anyways, why don't you label W, X, Y, and Z acid, base, conjugate acid, conjugate base. Time flies when you're having fun on a snow-filled day. I think everybody's done. Let's take a look at this. First thing you have to do is identify the conjugates, because that helps you. Conjugate exists. One side is always the acid, the other side of the conjugate is a base. Now if we look at here, HNO3, and here, nitrogen, 3 oxygens. What's the difference between this and this? 1 proton, also potassium. But we're looking at conjugates, we're just looking at H+. Now I have X, KOH, oxygen, hydrogen, and here I have water, and this differs by H+. Now, if we look at W, and I'll give it away, nitric acid, when it goes from here to its conjugate, does it gain a proton or lose one? And the answer is it loses one. 1 hydrogen, no hydrogen. And what's something that gives up H+ or hydrogen, if you're just using my quick counting, and that is an acid. So this is an acid. And then let's go to KOH, potassium hydroxide, and look at here in X, it goes to its conjugate, water, Z, has 1 hydrogen, it now has 2, actually picks up H+, and what's something that accepts a proton? It's a base, and therefore this is a base, potassium hydroxide. Now, let's go the opposite way. Now, there's a quick way, but I'll tell it to you, but I would still do it the long way. If this is a conjugate, if this is an acid, its conjugate is always a base. Well, let's find out if I'm wanting to or not. I could. And let's look at Y. When it goes from here to here, what has it done? Does it give up a proton or accept a proton? Count the hydrogen. 0, 1. It's accepted a proton. A proton acceptor is a base, and everything on the right side is conjugate. So this is the conjugate base. And finally, Z. Z goes from 2 hydrogens, water, to 1 in KOH. What's something that gives up H plus? It's actually losing H plus. And what do we call something that donates or gives H plus, or H plus donor? An acid, and it's on this side. The right side is always called a conjugate, and therefore that's a conjugate acid. And that's how you do it. And by the way, I was telling you the truth about the quick way. Whenever it's acid on this side, its opposite side conjugate is the base. Same thing here. If it's a base here, its opposite on this side is an acid, hence conjugates. And that's conjugate acid and base, and that's an important thing. Oh, speaking about, well, no, not yet. Too early. And I just did this seaboard for examples. Now, I'm turning the switch off for this slide, and acids and bases have different strengths. Acids, you can have weak acids or strong acids. And a strong acid is one of those types of acids that says, here, I have a proton, take it, whether you want it or not, because I'm strong. And they give up their acid, their proton, all the time. Now, I don't teach in here, but this an equilibrium. It can either go to this side or this side. When it's 100% to this side, that's a strong acid, because it's going to say, here's my proton, take it. You don't have a choice. And therefore, this would be a strong acid. And examples of strong acid are hydrochloric acid, hydrochloric, sulfuric, and nitric. In Chem 1, 1212, we use, or used to, I don't teach it anymore, but when we did, we used nitric and sulfuric. And I had a student who didn't follow instructions and got concentrated nitric acid on his skin and got a very bad acid burn. That would help in this weather. And strong acid, it really destroyed his skin. Luckily, he got it off quick, or I got it off quick, but still it hurt. Now, you can have a weak acid, and that's where, instead of saying, here, I'm going to give you my proton, says, oh, I'm a weak acid. Do you like my proton? Oh, if you don't want it, I'll keep it. And that's acetic acid, which is in vinegar. If vinegar, acetic acid, was a strong acid, and you used it in cooking, you'd be in the hospital awful quick. It's not. But it's still a pretty powerful acid, even though it's a weak acid, because in vinegar, it's very dilute. You learned about dilute. It's only 4%. Now, bases, same thing. You can have a strong base. And a strong base says, I don't care if you want it or not, I'm taking your proton. And the equilibrium is 100% to this side. And examples of strong base, sodium hydroxide, potassium hydroxide. Ammonia is a very strong base. And a weak base is one that says, could you give me a proton, please? Okay, if you don't want to give it, I won't take it. And a weak base is sodium bicarbonate, which we use in cooking, which is baking powder. And this is a weak base. If it was a strong base and you made bread with that or other baking goods and you ate it, you would be in the hospital awful quick. And like I said, weak base, the switch is still off. Now, it turns out one of the most amazing chemicals around, and I'm always amazed by it, is in this bottle, water. You don't think of it, but it's a chemical. And chemical, it turns out, can react with itself. And the reaction is, and I don't know why this dot is here, been attacked by the dreaded dot virus. But anyways, it's in equilibrium. And one of these can act as an acid, one of the molecules of water can act as a base. And you transfer a proton. And when that happens is you get the hydronium ion and the hydroxide. Now, if you notice, I have a tiny little arrow on top because the equilibrium is mostly on this, and water exists mainly as this, but there's a small amount of these species in water, and that's very important because that's in your blood and other things we use in our daily life. If you look at this water bottle, it has in there H2O, but also has a very small amount of the hydronium ion, H3O, and the hydroxide. And that plays a tremendous part in water. I have time though, because of the snowstorm, I'm going to let you out a whole 90 seconds early. I'll see you on Wednesday. Stop dreaming about a white Christmas so we can have better weather. And be careful.